The next part of our notes is dealing with the second half of the title, which was approximating radicals, giving a decimal approximation to radicals. So in order to be able to approximate radicals, we first need to know what a perfect square number is and make a list of perfect square numbers, okay? So let's make a list of perfect square numbers. And let me tell you this, the very first perfect square number is 1. What's the next perfect square number? Anybody? There you go, 4. And the next one? 9. And the next one? 16. And then? 25. And then? 36. And then? 49. And so on and so on. Where am I getting these numbers from? I am simply squaring each number. So if I say 1 squared, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on, till you get all these numbers. 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144. So ladies and gentlemen, this list right here is actually something that you guys need to produce. Now, what do I mean by that? Question, I think 15 on next week's quiz is this. It says, write the perfect square number list between 1 and 144. And you need to come up with this list. So it's not like you have to memorize it. Just think, what's 2 times itself? 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 36, 49. 8 times 8, 9 times 9, 10 times 10. So you write out this list from 4 to 144 and you get credit for that question on next week's quiz. Please take a moment and write this down. Write down perfect square number list and write down those numbers between 1 and 144. Those are all the perfect square numbers. Once we know how to create this list, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, we need to know that if we were to take the square root of any of these perfect square numbers, we're going to get a perfect answer. What do I mean by perfect answer? A natural number, right? Check it out. Let's say I took the square root of 9. What do I get? See, it's a nice, beautiful answer. It's a natural number, right? What if I took the square root of 121? What do I get? I get 11. Nice, beautiful answer, right? What if I took the square root of 16? Nice, beautiful answer. You guys get it? So this fact we know. If you take the square root of any of these numbers, you get a nice, beautiful answer. As a matter of fact, let me do this. I want to go back to these numbers right here, and I want to put a square root. I want to put a square root on all of them, and I want to get the actual square root so we could see those answers. So when I do take the square root of each of these answers, or each of these numbers, I get nice, beautiful answers. I hope we all understand that and agree. What do I mean by this? The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. So yes, it's true that when you take the square root of a perfect square number, you get a perfect answer. Now, that brings us to this. What if I say, what's the square root of 48? That is not a perfect square. That's not a perfect answer. The square root of 48 is not a perfect answer. It's actually an irrational number. Now, we know about irrational numbers. They're long, crazy decimals that don't make sense. However, what I want to do right now, I want to give an approximation, a decimal approximation of the square root of 48. Actually, I shouldn't even put equal. What I should put is the approximation, which are kind of squiggly equal signs. Now let's think about this, guys. 48, where's 48 at? The square root of 48. Is it close to 9? Is it close to 121? Where's the square root of 48 close to? It's close to the 49, right? Okay. And yeah, it's between 6 and 7. But let's think about it. It's super close. 48, it's not that close to 36. It's actually really close to 49. Exactly. So the answer has to be really close to the answer 7, but we know it's a little bit less. So we know that this answer down here must be about 6.9. Whoa, sorry. Let me erase that first dot accident. There you go, 6.9. that is an approximation of the square root of 48. So if I asked you, give me a decimal approximation for, let's say, the square root of 26, what would your decimal approximation for the square root of 26 be at? 5.1. Now, it's okay. This is the very second time we're looking at it, so it's okay to make mistakes. Now, what do I mean by this? The square root of 26, where is it at? It's really close to 25. Is 26 before 25 or after 25? After. So is your answer going to be before 5 or after 5? After. So really close after 5 would be 5.1. Does that make sense? Now, if I were to have done maybe the square root of 24, let's say that, the square root of 24, then you would say, okay, where's 24 at? Oh, 24 is right before 25. It's not, I mean, it's between 16 and 25, but it's right before 25. So what would my answer be if my answer has to be right before 5? 4.9. 4.9. What do you guys think? Let's try another. What if I said, what is the square root of 50 as a decimal approximation? Well, we know what the square root of 49 is. What's the square root of 49? 7. So the square root of 50, yeah, 7.1. The square root of 50 has to be a little bit more than the square root of 49. So the answer has to be a little bit more than 7. So it's going to be 7.1. Okay? 7 point, that's the ugly 7 right there, sorry. 7.1 would be a good decimal approximation. You guys kind of get it? Now let me throw a curveball at you, because so far all of these, oh, this one's right before 25. Oh, this one's right after 25. Oh, this one's right after 49. What if I told you to approximate the square root of, let's say, 91? 91. Where's that at? Is it? It's over here? No. Where's it at? Between 9 and 10. Now, is it super close to the 9 or is it super close to the 10? Is 91 super close to 81 or is it super close to 100? Or is it kind of in the middle? It's kind of in the middle. So right here, what would a good decimal approximation be? 9.5, kind of in the middle. Now, all of these are irrational numbers. If you actually did the square root of 91 on the calculator, it's going to give you a crazy long infinite decimal with no pattern. But right here, we're approximating them just by understanding the perfect square number list and by looking at where it would fall. Oh, 91 is perfectly, well, not perfectly, but pretty much right in between. Oh, I'm sorry, right here. Right in between 81 and 100. 91 is right in between. It's not 82. It's not 99. 91's pretty much right in between. So our answer must be in between 9 and 10. So we say it's 9.5. What do you guys think? What about the square root of, let's say the square root of 20. I'm even going to write it right here. What would you say the decimal approximation to the square root of 20 is? There you go, 4.5. So on approximations, it's really, I recommend using either 0.1, 0.9, or in the middle, 0.5. Okay? And there will be a couple of these on the quiz also. What do you guys think? It's easy.